we are discussing NSGA2 approach, and the NSGA2 approach follows some method similar to the NSGA, and it is basically the first method, first step that is there in both common in NSGA and NSGA2 are non-dominated sorting front calculation based on the non-dominated sorting or procedure. Now today, and then the next procedure that is there is different, is basically the selection for the mating pool, and here in the NSGA we follow the method of assigning fitness values followed by the sharing fitness values, but in case of NSGA the method that we follow for the selection is basically called the crowded tournament selection. So in this lecture we shall learn about this crowded tournament selection method. So crowded tournament selection method in NSGA2. Now as we know that crowded selection method is basically crowded tournament selection method is basically required in order to decide from the last front to select the requisite number of solutions to fill this population of size F1. So here if this is the last front that needs to be considered to fill this front, but if we include all the solution belong to this front, it will exhaust the total capacity. So from there we have to calculate only this amount of numbers to be included here, so that the total size of this solution will be equals to n. So now how to select the correct solutions or the most preferred solution to this one, and this method is basically based on the crowded tournament selection method. Now so this is the crowded tournament selection method will be discussed in these lectures. Now the crowded tournament selection method, it is also called crowding sort procedure. It basically consider two concepts. First is that the measurement of crowding distance, and then another is called the crowding comparison operator. So there is one metric, if xi and xj are given, then how to find the crowding distance, or rather we can say for every solution xi how the crowding distance can be calculated. So this is denoted as d, and then if xi and xj are the solution, then how we can say that which is the winner, that is based on the crowding distance measure that we have, because xi has its own crowding distance, xj is one crowding distance. Then selection is based on an operator that is called the crowding distance operator, that can select the winner, that means it is compared based on this operator, this one. Now crowding distance di, if we denote of a solution xi, is in fact is a measure of the search space around xi which is not occupied by any other solution in the population. So physical meaning of this crowding distance is like this one. If xi, this is the one solution here, and then how many space it is there by which the next the neighbor is there. So this is the crowding distance. Now if this is the solution xi and this is the crowding distance for the next neighbor it is there, then we can say that crowding distance of this solution is more than the crowding distance of this solution. Now another physical meaning is that if the crowding distance is very large, this means that this is the one solution which is there in a less populated one region. On the other hand, if the crowding distance is small, then we can say that this solution belongs to one solution which is highly the populated. So is basically crowding distance says that whether this solution is in a crowded region or this solution is in a crowded region, or both the solutions in a crowded region, then which solution are in a heavily crowded region than the others. So this is the meaning of this crowding distance concept, it is there. And then crowding operator, this one is basically to compare the two solutions so far their crowding distance is concerned. So these are the two things are there, and we will discuss about these two things here. Now let us first define the crowding comparison operator that just now we have discussed, by which the two solutions can be compared, and based on this comparison we can select the best solution there. Now, let us consider xi and xj are the two solutions, and their the crowding distance is known to us also. Now, so crowding comparison operator is basically is a operator which is defined here. How this operator works for us? So, here the operator is defined like this. If solution, there are two conditions actually. If solution xi has a better rank, that is rank xi is better than rank xj, that means xi is in a higher rank, I mean is a better rank than xj. Now, rank actually you can remember I told once that all the solutions which are the first front, they can be considered as a higher rank, and then next solutions which are in the next rank is the next rank, and so on so on. So, xi is the first front and xj is the next front, then we can say that this one. So, here this is the one condition that is to be satisfied, then we can say that xi is the winner than the xj. On the other hand, there is another condition, if they have the same rank, but solution xi has better crowding solution than xj, that means it has better crowding distance than xj, then xi can be considered as the winner than the xj. So, the two conditions are to be satisfied, and based on these things it will basically selects the winner. So, the conditions again, rank xi, if it is rank xj and di is greater than dj, then xi is the operator. So, this is the idea about the crowding operator. So, this means if xi and this is the crowding operator xj is basically checked out of the xi and xj, which has to be returned. So, either xi or xj. So, based on this condition, so this operator is defined here. So, this is the concept that is there so far the crowding sort is concerned. Now, let us see how this concept is there. In our case, if we see in our case, that means we are to consider all the solutions belongs to a particular front, that is the last front. So, therefore, rank is not required, the first condition need not to be satisfied, because all the solutions belongs to this front have the same rank. So, that is why the first condition is not need to be checked there, only the second condition need to be checked. So, second condition resolves the tie when basically if both solutions belong to the same front, but the solution, the tie can be resolved by means of calculation of their crowding distance, or in other words, in NSGA 2 only the second condition is valid as all solutions belong to only one front. Now, let us see how the crowding distance measure can be carried out. We have already told you that crowding distance measure is basically the population density surrounding a solution, but how we can measure this population density? NSGA 2 follow a clever approach to do these things. So, according to this NSGA 2, crowding measure distance di for a solution xi, that means the ith solution, is an estimate of the size of the largest cuboid enclosing the point xi without including any other point in the population. So, this is the definition actually. So, that is the largest cuboid enclosing the point xi, this is important. That means, if xi is given to us and if we are able to find the largest cuboid which surrounding the xi, so that there is no any other point in that cube, then that cube will give a measure to the crowding distance. So, this is the idea about the definition of crowding distance as it is there. I can illustrate the same concept with an example here, let us follow. So, first consider this example, and it is a case of two dimensional, that means two objective f1 and f2, and for solution say x2, we want to find the crowding distance. Now, surrounding these 2 points, the 2 nearest point with respect to x2 is this one, say xi minus 1 and xi plus 1. These are the 2 nearest point with respect to the solution point x2. Now, then with the 2 nearest points, that is x2, with respect to this we can find one what is called the region, it is there. So, this region is basically is the crowding region here, that means surrounding this x2, these are the basically area by which no other points are enclosed. So, the x2 is the crowding measure here. Now, the x2 measures is basically the crowding measure is okay, we can take the calculation of the square of course area, but this NSGA2 propose the measure that this plus this is the measure of this crowding distance. It is also alternatively, because if these 2 measures basically breadth and width measure in this case. Now, so this way if we know x2 and these are the 2 solutions are there, we will be able to find these 2 distance, and therefore, the crowding distance can be measured. So, this is the one example where the crowding distance how it can be measured here, and another example. So, this is another example here. 3 objectives are there. So, it is a multi-objective optimization problem with 3 objective functions f1, f2 and f3, and we are interested to find the crowding distance for the solution xi, and suppose xi plus 1 and xi minus 1 are the 2 solutions which are the nearest to xi, they are the nearmost 2 solutions. Now, if we can find the 2 solutions which are nearmost to this one, then in 3 dimension, unlike this 2 dimension, we can find a cuboid. So, this is the cuboid and this one, and then the crowding distance of this thing is basically this is the total area of the cuboid, but instead of calculation of area of the cuboid, it will take the calculation of this and this are the measure of the size of the cuboid. So, this will give the measure of the cuboid, and then this can give an alternative measure, or is basically the measure of the crowding distance. So, we have learned about how the crowding distance for any solution in a 2 dimensional space can be calculated, for any solution in 3 dimensional space can be calculated. Now, extending the same idea, we will be able to calculate the crowding distance for any solutions, but in a n dimensional space. Now, we will give an idea or the formula that the NSGAT authors proposed it, how the crowding distance can be calculated will be discussed. So, anyway, so crowding distance can be calculated if a solution is given knowing the other solutions in the near vicinity of the solutions. Then the crowding okay, so is basically the crowding distance, and then once the the idea is that for all the solutions which are belongs to the last non dominated front, for all the solutions belongs to the last dominated front, we have to calculate the crowding distance for all. So, this is the step that is required here. Now, crowding distance calculation can be carried out in a little bit mathematical way, that just I want to discuss it here. Say suppose given a set of a non dominated front, the last non dominated front that is there, let this be f, and there are objective m objective function for each solution, they are denoted as f1, f2 dot dot fn. So, for each solutions we have this objective vector f with in terms of m objective functions, and let the size of the f be this one, that means the number of solutions which belongs to the non dominated front, this be the I. So, here basically the procedure is that for each xi in f, set di equals to 0, initially the crowding distance of all the solutions is 0, and then we will calculate for each solution xi in f what is the crowding distance, we have to calculate it, initialize 0 and then finally we have to calculate the crowding distance for all solutions. Now, here is the procedure for each objective fi in f, basically we will first sort all the set f, but with respect to the ith objective vector, and this be the sorted f. So, it is the idea, it is like this. So, first with respect to f1 objective function, we are to sort all the solutions which belongs to f, and then the sorted solution will be termed as f1. Similarly, with respect to f2, if we sort all the solutions belongs to f, and it will give f2. So, this way, if with respect to fm, we can get the sorted version of solution fm. Now, here we can see, so these are the sets is a sorted order, but is a sorted order with respect to one component. This one sorted with respect to f1, this one is sorted with f2, and this one is sorted with to fm, and so on, so on. So, here basically a sorting techniques are to be followed, by which all the solutions belongs to the set f can be sorted in terms of one objective function at a time. So, these are called the sorted vectors. So, pictorially all the sorted vectors can be shown like this, if you can see this figure here. So, these are the sorted vectors, we can say f1 sorted vectors with respect to the objective function f1. So, here basically all the solutions, they are sorted in ascending order, but with respect to f1. That means, these solutions has the lowest value, so far the f1 is concerned, this is the next highest value, and it is the highest value of f1 is concerned. Now, again, and this is the solution f2 with respect to the second objective function. That means, with respect to second objective function, all the solutions are there which has the lowest value of f2, then this solution which has the next higher value, and so on, so on, and this basically the solution which has the highest value, so far the objective function f2 is concerned. So, this way the f1, the sorted vector f2 and fm, and here with respect to fm can be obtained. Now, in this discussion we assume one concept is that here all the objective function are to be minimized. So, now if it is not minimized, rather if it is to be maximized, then we will follow the descending order. So, if it is minimized, if it is maximized, then it is ascending order, it is descending order. So, this procedure depending on. So, we can consider that all objective functions are to be minimized one. So, if it is a minimized, then all these are the ascending order of their objective function. So, this way the sorted vector can be obtained. Once the sorted vector is obtained, then we shall be able to calculate the crowding distance between crowding distance of each solutions easily. So, this method that is proposed in the NSGA2 is like this. So, the crowding distance dj for any jth solution can be obtained like this one using this formula. This formula can be checked yourself and you can find it. Here the fk max and fk min are the two values. It means, with respect to the kth objective function, what is the lower bound and the upper bound, and this value is used to normalize all the solution, because is a normalization is required, so that all values of the dj will be in a same range. So, this is for the normalization, and this formula can be verified yourself. And another thing is that the first solution and the last solution, this is basically di, the last solution, because it is a boundary solution, they have crowding distance is infinite. So, this is the condition. So, this way we shall be able to calculate the crowding distance of all the solutions there. Now, once the crowding distance of all solutions are calculated, then we can play the crowding sort procedure here. Okay. So, here we have mentioned that all objective functions are to be minimized in our previous discussion, and so far the complexity of the crowding distance calculation is concerned, because it is a sorting method. So, its sorting complexity is mn log 2n, where n is the size of the population. So, the complexity is this one, and fk max and fk min are the two limiting values and then we divide this limiting difference between the limiting values to normalize objective values. Okay, so crowding distance calculation, once it is done, then we will be able to play the crowding tournament selection game. So crowding distance selection game is basically, it is like this. We can follow the crowding comparison operator. Now here so crowding operator can be applied to the two solutions xi and xj. That means we have to see this one. Now here xi crowding operator xj and xi will be termed as a winner if we see that their crowding distance di is greater than dj. So in this case, this is the crowding operator here, and you can say again that all the solutions are belong to the same rank. That is why you don't have to bother about rank. So here basically, so far the crowding distance based tournament is concerned, we prefer those solutions which are not in the crowded search space. This ensures a better population diversity. So basically di is greater than dj, that means the solution xi is not in a crowded region. Now so this basically to ensure the population diversity. It is same concept that is there in NSGA, but NSGA follow the niche count. Here instead of niche count, it basically considers crowding distance. So this is the difference between NSGA and NSGA 2 is there. Now NSGA 2 is an elitist approach. Why we said so? This is because if you see the non-dominated front, it basically when we merge the two solutions, the previous generation and the next solution, and from there if we find the non-domination front, then it basically selects the all elite solutions first. So that is why it is called the elitist approach, because first front, second front, third front and the elitist fronts are selected first, and for the last front it is the lowest or worst elitist front. From there we have to select from using the crowding tournament selection. So here this is why the concept it is there, and so far the procedure, the time complexity is concerned, the total time complexity here is order of mn square compared to order of mn cube there in NSGA concept, and it does not require any explicit sharing concept that is there in case of NSGA method. Rather it uses a crowding tournament selections with time complexity order of mn log n. Now so the two time complexity order of mn log n for the crowding tournaments and for this order of mn square for the non-dominated sorting procedure, putting these two operations, basically complexity is order of mn square only, because this is the higher bound than this one. So it is basically taken this one. On the other hand, in case of non NSGA, it is order of mn cube, and obviously so it is order of mn cube, and out of these two complexity, this is the time complexity with the lower effort than this one. So that is why NSGA is a fast method. So it is a fast method and it is an elitist method. So this is the idea about there, and accuracy, it is observed that this algorithm gives better result compared to any Pareto based approach that we know so far, that means MOGA approach, NPG or NSGA. It gives better result and with the fewer competition compared to NSGA of course, and obviously if we consider time complexity, then it needs more time complexity compared to MOGA and NPG however, but the complexity is better. So these are the different Pareto based approach we have learnt, and what I want to say in the summary is that out of the different approaches to solve multi-objective optimization problem, non-Pareto based approach needs a priori knowledge, whereas Pareto based approach does not require any prior knowledge. So this is the one advantage that the Pareto based approach is there. And another difference between the non-Pareto and Pareto, that non-Pareto gives only one solution, but all the Pareto based approach gives Pareto optimal solution, that means trade off solutions. and then from the trade of solutions we have to decide one solution, and that solution require some posterior knowledge. That means it is depends on your decision that okay, out of these solutions which solution can be considered. But in case of Pareto based solutions or Pareto optimal solutions, we can select any solution out of a large set of solutions that can satisfy your requirement. So, this is the difference between the Pareto based and non Pareto based approach, and as we told you, the non Pareto based approach, it is applicable if we see that only fewer trade off solutions are to be considered or it is there in the problem solving. On the other hand, we should apply Pareto based if we see that there is a large number of solutions are possible which are equally towards the optimum solution. So, in that case we follow Pareto based approach. Out of this non Pareto and Pareto based approach, in fact people prefers Pareto based approach because of its accuracy and then performance. Okay, first, so this is the technique that we have learned about multi objective optimization problem solving using genetic algorithm. So, our next topic in the next field we will discuss about neural network concept to solve some computing problem in different application. Thank you.